Okay, good morning, Year 9, you wonderful people. We've just finished percentages, so we're moving on through the book. The next chapter is a really meaty chapter. It's got loads of different stuff in there, and it's all about algebra. It's a very, very important chapter that we need to get really, really into. So what I want to do is just go over some of the basic not these basic principles because I don't like those. But for example, these things here, simplifying algebraic fractions. Now, I don't think this gives a very good explanation to anything at all. So I thought I'd just go over uh, some of these examples just to show you what's going on. Okay, so I got my trusty little pencil here, and it says simplify these. Now, what does it mean by simplify? It means find cancelling factors. Okay, so the factors in the numerator, I'm just going to look at number one. Factors in the numerator are 4 and x. So I'm going to rewrite that as 4 times x. And the factors in the denominator are 1 and x. So I'm going to write that as 1 times x. This is very much a how video as opposed to sorry, this is very much a why video as opposed to just a how video. Because how videos, I could just say, well, there's an x there and there's an x there. They cancel, and you end up with 4. 4 is the right answer here, but why do they cancel? Now, this here is a fraction. Now I'm just going to take one step back before I get to the answer. If I have a fraction 2/3 and I times that by 1/2, okay, you remember from fraction multiplication that that's just 2 times 1 over 3 times 2, which is 2 over 6. Okay. Now, here in our first example, I'm actually going to do what I just did, but in reverse. I'm going to rewrite this as the product of two fractions. Okay, so now we're left with something which should be a lot more obvious that it actually cancels out as to why it cancels out. Because 4 over 1, 4 divided by 1, anything divided by 1 is itself. And x over x, well, anything divided by itself is just 1. So 4 times 1 is 4. So that's where those different factors, that's where they cancel to. Okay. Now, I'm going to do a slightly more tricky one. Let's do this one here. Question number 8. I'm going to write 4 times a over 4 times 2 times a. Okay. Well, using the same approach, I'm not going to rewrite it as the product of different fractions, but what I am going to do, because I've lined them up in such a way, this way, I can see really easily where things are going to cancel out, and you'll see why I rewrote 8 as 4 times 2. The a will cancel with the a because I'm going to get a over a. The 4 will cancel with the 4 because I'm going to get 4 over 4, which is just 1. And I'm left with just those middle bits, which is a over 2. Okay, so what do? We look for these things. We look for common factors. So the common factors of the numerator and the denominator are a, because I've got an a down here and an a up there. And I've also got common factors in the numerator of 2 and 4. So when we're when we're simplifying, it's all we need to do is find those common factors and divide both the numerator and the denominator by that common factor. I'll show you what I mean again. If I've got 4 times, let's undo that. So if I take 4a squared and over 8a, I can see that 2 is a common factor of 4a squared and 8a. So I'm going to divide the numerator by 2. Well, 4a squared becomes 2a squared. Nothing wrong with that. And 8a becomes 4a. But I can still see that there's another common factor, the common factor of 2. So I can now divide by 2, and I get a squared over 2a. You don't have to always do all the cancelling in one step. That will come with more practice. Okay. Now I'm just going to jump again to question 12 here, and I'm going to rewrite this. This says divided by, but what it means is it's going to be a fraction. So I'm going to rewrite it as a fraction, 3a squared b squared over 12ab squared. I look for my common factors. I've got a b squared in the top and the bottom. I've got an a in the top and the bottom, not an a squared. And I've got a 3 in the top and the bottom because 12 is 4 times 3. So what's going to happen? The b squareds are going to cancel. One of the a's is going to cancel. And the 3 is going to cancel with the 12. 12 divided by 3 is 4. So what am I left with? A mess. A really horrible mess, but it's just a over 4. Okay, so that there is just a very, very quick explanation as to why cancelling happens. And the rest I'll let you have a go at just practicing those. Now, the next exercise is simplifying. Well, this is just one more thing, really. If I take this number here, whoo, didn't mean to do that, sorry. And, well, I'm just going to multiply them together. Now, there's a thing that we can do here called cross-multiplying cancelling, because I know that I can just multiply these together, and there's nothing wrong with doing that. And that gives me 3, sorry, it doesn't give me 3. It gives me not 5 either. What am I doing? What am I talking about? My daughter is laughing at me because of my stupidity. 3 times 5 is 15. X times x is x squared over 4 times 3, which is 12. Now, we can do that if we want, and then we can simplify. We can simplify by saying, well, I can see that we've got one common factor of 3 in both the numerator and the denominator. So that's going to leave me with 5x squared over 4. But there is a faster way of doing it. So I can see when I'm timesing these fractions, one of the nice things about, do you guys remember the law of commutativity? Where it doesn't matter which way round things get multiplied, you still get the same answer. So what I'm going to write here is 3x times 5x over 4 times 3. That's me just doing that. But then I can also rewrite that as 3x times 5x over 3 times 4. And then I'm going to split it back up into the two fractions. 3x over 3 times 5x over 4. Now, it's very easy to see that the 3's are going to cancel out, and the x's we just have to put in back into the question. Now, when you get fast at these things, you'll notice that on question 1, I can see a 3 there and a 3 there. So I can just go, well, they're going to cancel in the future. So I can just cancel them out right now. Okay. Similarly on, I don't know, for example, let's look at question 3. Okay, I can see I've got an x squared there and an x squared there. They're going to cancel at some point. I've got a y there and I've got a y there. They're going to cancel at some point. And I've got a z there and I've got a z there. They're going to cancel at one point. So the answer to that one is 1. Goes from something very complicated to something very, very simple. This comes just with a lot of practice. And remember one thing. This only works with P, no. With multiplication. Multiplication, that's right, Eleanor. It only works for multiplication. So for example, if I have 3 plus x over 5 plus x, those x's do not cancel out because there's no way of rewriting it as it's not 3 over 5 plus x over x. That just doesn't work. It's stupid. So we don't do that. So it only works with multiplication. What about division? Well, 3x over 4, sorry, I'm looking at this one now. 3x over 4 divided by x over 8 is the same as 3x over 4 times 8 over x. And now here I can see boom, 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 4. Done. That's going to give me 3 times 4, which is 12. Right, you get out. Okay, so abscond, child, abscond. Outside, please. Now, go, 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 go. Put your stuff on Class Dojo. Right. So, and again, with practice, you'll find that when you're doing division, I can see now I've got 2x there, and I've got 2x there, I've got 3 there, and I've got 3 there. So that's all going to cancel down to 1. So these ones here, these are the first ones that I want you guys just to get really, really super good at doing. And the difficulties of if you multiply things out, sometimes you actually make things more difficult than they actually are. So subtraction, addition and subtraction. I think this one's a little bit better. I'm sure you can be able to follow through that one there. Simplifying these. Yeah, I think this part here, solving equations with roots and powers, I think you're all pretty much aware of how to do that with the whole peeling of the onion thing and how to get rid of square roots, you square it, how to get rid of squares, you square root it, things like this. These are all important things to know, and they just take a little bit of practice, really. It's about finding the inverse function, really. So now we're on to solving equations. I'd like you to have a go solving these equations. This is an extension of the one that we did a couple of months ago, actually, where I said you've got to make sure that we go through every single one of these questions. And this is exactly the same. Positive integer indices. I think this actually is explained very, very well right here. They do exactly what I would do. The only thing they don't do is when they're saying for division here, well, where does that happen? Where do you get a to the 4 divided by a to the 2? Well, that's going to cancel with those. And that's why you have that subtraction of the indices. That's the only reason there. But like I said, I think that's quite a good explanation right there. So feel free to go through these ones as well. Again, just taking your time. Inequalities, I think they're, you'll be good at these. The only thing that we really need to have a look at is that thing over there, where all you do is you put curly brackets and you put all the solutions inside. And if there's an infinite number of solutions, you just put dot 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 to say that those go on forever. That's not terribly difficult, but important to be able to do. It gets a little bit more hairy right here, in fact. But again, nothing that you are unable to do, nothing at all. Greater than or less than, these things here as well. We have done these before, and it shouldn't pose too much problem. It's all about just getting in that good amount of practice. I said it before, fractions, you need to be able to work with fractions, work how to simplify things, how things cancel, and to be able to just solve simple linear equations. Once you get those things under your belt, you'll be absolutely fine. So have a go at going through this unit. This is what we're going to do, I think, for probably 2 weeks, actually, because I think it's one of the more important units because it just requires so much understanding to really get the most out of this unit. For example, the next chapters Oh, the next chapter's graphs. That'll be nice and easy for you as well. But this one here, super important. Let's do it for a week and see how it goes. I think we'll probably be on this for 2 weeks though. Okay. And as always, if you have any questions, send a message to me or my daughter if you really want. She'll try and help you answer your questions. No, she won't. All right. See you later.